welcome back to the NES Game Maker. So last time we put in the finishing touches for our Link object, our side-scrolling version of Link. And now we have pretty much every single state that we're going to be using in our player object. There's just a few last things to set up, such as make sure he takes damage from actual enemies and stuff, but also projectiles. And, well, there's other things like experience and, I don't know. We'll figure it out as we get to it. Talk box interaction. Yeah, that kind of stuff. But anyways, beyond all that, we're going to get into one of the things that most people really want to hear about. How to make enemies. So let's get cracking on that. If we come in over here, not there. I wanted to go to Windows, close all. We're going to come over here to our side object, and we're going to make a new group here. Create group. Call it enemies. And let me move some stuff around over here on this side. Alright. So we are going to start off with the most simple enemies. Bit and bot. We're going to create an object. We're going to call it obj_enemy_bit. Now, you'll notice that there's a bit of a method to my naming here. So I have object, type of object, then name of object. So why am I doing it like this? Well, it doesn't really matter too much here in this tutorial. But let's say if we come over here to my Infinite Runner game that I've been working on. If we come over here to my sprites. And I have all these background scenes, such as the city during the day and the city at night. So I have sprite, background, city, day, layers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Right? Why is that all important? Because basically this allows me to craft strings using this little bit here. And I can insert in background type, city, daytime, time, day or night, and I can also adjust the number by just in the string, and that allows me to dynamically craft the capability of being able to change around the sprites as needed. And you see this somewhat in the Chip and Dale tutorial where I have it set up so that you can insert in either Chip or Dale into all the sprite names. So you can have either Chip or Dale as the player character, right? And it's kind of the same thing here with the enemies. So well, it's not really super important in this tutorial. I kind of do the same thing here with the code because, well, it's just my habit at this point. You know, it's a good habit to make. Have little ways that you do things that make it easy to say, oh, he does all these things this way, so that makes it easy to identify what you're doing in the future if somebody else were to come along and read your code. That's one of the things I try to always do. So let's start off with over here by giving you a parent. Object, parents. And remember how that is parent enemy we made. So we're going to give you that. And if I remember correctly, in this case, we don't need you anymore. Because the parent enemy doesn't actually do anything in this game. But, okay, yeah, just make sure I didn't have any children assigned to it other than Bit at this point. But we're going to need a create event, we're going to need a step event, we're going to need a draw event. We're going to need some user events. 0, 1, and 2. So after a lot of studying and whatnot with watching all his actions in the game, I came up with what are the states that Bit exhibits in his actions. So we have an idle state and a move state and a dead state. Move state. Oh, I put that in the step event for whatever reason. State. There we go. And he exhibits those different interactions as far as I can tell. So let's come over to the create event. We're going to copy a lot of the code from our link object basically into our create event here. Because like I said, I have created all these methods and I basically can now apply them to everything else. And if you've ever read that excellent article by Pixelated Pope about creating objects, creating enemy objects that can be taken over by the player at any time should the player, if you were to give the player that capability, and they play just like the player. And that's basically what we're doing here. We're creating objects that play exactly like the player, except they're semi-autonomous. So we're going to come over here, copy in that code. First off, we have our change state method. We also have this take damage. We'll cancel this for the moment because we're not doing, we'll come back to it when we actually do damage. Then we have bit states. So unlike the player who has player states, we have bit states because he has his own proper name and his states for whatever he's doing. He has idle state, move state, and the dead state. Animation. Let me zoom this in, by the way, since I'm thinking about it. And we don't need these. So there we go. Animation, image speed, image X scale, -1. Don't think it really matters because he's symmetrical. Speaking of which, let's give him a sprite. Come down to our sprites, enemies, bit and bot. Now we have bit idle and bit move, so we're going to give him bit idle. I think the only reason why this is here is because like I said, I copied it from the player and I didn't get around to it, and I didn't go around changing this. So anyways, direction, target direction, again, age right, because he's targeting to the right by default and he's facing to the right by default. State, bit states idle. We wanted to start in the idle state. Frames, his iframe length is 0.3. And his damage flash length is 1 second. So, unlike the player who flashes for a shorter length of time than iframes, his iframes are shorter than the flashing section. So, I think that I did the logic for this somewhat differently, I believe, at this time. I can't remember all the details about it. I'll think about it when we actually get to the damage part. Anyways, that's the flashing speed, which is how often these flashes. And manual sprite changes, palette index, make sure you set it up to sprite palette bit, because instead of using the sprite palette link, we're using sprite palette bit. And HP is 2, so these are stats. This is a new region for him. His damage is 4, and his experience he gives is 9,199. Because we all know that Bit is the most difficult enemy in the game, so he gives you the best reward. That's actually not a joke. Bit bots are basically the most difficult in the game according to speedrunners because they're basically unpredictable. They're random in their movement, so they can jump at you at any given time, and you never know when it's going to happen. And that is, for a speedrunner, the most difficult thing possible. At least that's what I hear when I watched all the what are they called, the Summer Games Done Quick episodes. Anyways. So X fractions, ground speeds, accelerations, etc., etc., etc. So we have 0.1 for their acceleration, 0.05 for friction, 0.01, etc. You can take a look at all this stuff if you want. They move at 2 pixels, actually. They have 2 walk rates, so they have walk speed slow and walk speed fast. So they can be shuffling along at 2 pixels per second per frame, or they can be shuffling along at 4 pixels per frame, and it's random which one they choose to do. And everything else should be in there. Coming down to our sprite table. I don't know if I need wall checking on this, by the way. I can't remember if I use it. Anyways, make sure we set up our sprites properly as well. When you're dead, you have no sprite. So that's all no one. Let's come over to our step event. And it's going to be similar to our player again, except slightly different as well. So we have pausing. If instance exists, object pause, then image speed is equal to 0, and exit. Our ground check is basically copied from the player object. So I'll make sure you can see that. But yeah, it's basically copy it from the player object. Damage check. Again, we haven't added damage yet for him, so we'll get around to that in a little bit. State execution, same as the player. Timers, we have the state switch timer, which is slightly different. Make sure you actually add that in over here, by the way. State switch timer, sec times 1 as your initialization. So after 1 second after creation, he'll change to a new state. And damage flash timer. And in the damage flash timer, once it resets, make sure you also reset the palette index back to 0. That's important for the flashing. I believe that's also in the player as well. Maybe not. Palette index is there. Did I remember to put that in? Maybe it's in some of the draw stuff I haven't added into the link yet for the future. Anyways, we'll get around to that. So that timers. Let's see. Idle state. So this is how he's going to start off in the idle state. It's going to be relatively simple. He can only go into the move state. There is no acceleration. So current X speed and applied X speed are 0. No speed fractions, no collision movement. All he does is quiver and animate. So he just does this little growing and shrinking animation and doesn't move. So easy, easy, easy. Animation, image speed equals animation speed. Make sure you get that in there. And frames of state. So how do we go into the move state? So if round state switch timer is equal to 0, again, I'm throwing in these rounds here at random. I haven't actually come up with a good system for how I'm going to do that yet, but I'll get around to it eventually. If round state switch timer is equal to 0, then change state bit state.move. So once the state switch timer, which we're counting down over here towards -1, reaches 0, then we go into the move state, and the state switch timer is equal to set times I random 1 to 12. So I just kind of sat there for a while watching bit and watching how long it was between state switches, and it seemed like anywhere between 1 to 12 seconds between the state switching. So from the idle state to the move state. So I just threw that in there random. Walk speed is equal to choose walk speed slow, walk speed fast, or negative walk speed slow, or negative walk speed fast. Again, like I said, it seemed to be chosen at random, and yeah, just choose randomly left to right. Event underscore user. Oh, wait. I can't remember if it actually... Oh, no. The walk state for bit is random. I'm thinking about the jump state for bot, where he actually jumps towards the player at all times. So we'll ignore that for the moment. So move state, you choose one of these walk speeds as your walk speed during that time. So let's go over to the move state. It's going to just basically be a carbon copy of other move states. So we can go back to the idle state once the state switch timer is equal to 0. You go back to idle and set it to 1 second. So it'll switch back to, so when you're in the idle state, it's always in the idle state for 1 second. And then you could be in the walk state from anywhere between 1 to 12 seconds after that. So, yeah. Event underscore user state. And we'll go back to ignoring that. Acceleration, there is no acceleration. It just instantly starts moving at speed. So if animation underscore end applied underscore x speed is equal to walk speed. What is this about here? So what I was saying is if animation end. Okay, yeah. He only actually moves at the end of his animation cycle. So at the end of every single animation cycle, so basically every 4 frames or 8 frames, he does his movement. So the animation cycle is a 2-cycle animation. So he has his flat state and then his high state, and then he just sort of bobs between them and moves each time he does that. So we're basically saying whenever he's at the end of his animation, give him a full 2 or 4 pixels movement. Otherwise, have him move 0. And if he walked off a cliff, have him fall. Basically, the same as normal. Speed fractions, same as always. Collisions of movement, same as always. Animation image speed is equal to 1. I could basically just say equal to animation speed, same thing, right? Frames of state plus plus. All right, that's all easy, right? Seems good. And then, of course, we have the dead state. We'll get around to that once we start adding in some damage. But to get us started with, we're going to come over here and give our enemy a test. Let's kill that. Make sure you get rid of that object from the previous test event. And he's invisible. But I can take damage from him. That's right. I forgot to put the draw state in. See, that's why we do these tests. There we go. We got draw state. Okay, so we're going to put in a little bit extra code here. We have this draw sprite exe, which is, like I said, basically draw self. The only reason why I have it here instead of draw self is because I specifically wanted to say, oh, make sure that you draw all these things properly. If I wanted to edit one of these various properties, I could change it by having it all written out. In this case, we have palette underscore swap underscore set and palette swap reset. So you wondering what these are? These are part of our palette lib palette swap. And all in all, it's a whole bunch of code that goes into setting up the shaders that allow for the palette swapping. If you're interested in the details, well, you can go and check out my palette swapping tutorial video I made. I put one together somewhere, I believe. At least in one of my previous tutorials I did. But suffice to say, it basically gets the pixel color at every single pixel in your sprite and says, is this pixel equal to the default sprite pixel? If yes, then swap it to the new sprite pixel. So, and the new sprite is whatever it's based off of in your sprite palette. So here's the default. So it says, okay, if this pixel is black by default, then if your palette index is currently 1, set it to orange. If your palette index is 2, then set it to olive. I believe that's olive, right? When I was a kid, I didn't understand that olives were actually green because all I'd ever seen were black olives until I was a little bit older and I didn't really connect it. So, anyways. Draw event. So we take our palette swap shader, set it to our palette sprite and our palette index, and then we reset the shader after drawing. And this happens if the damage flash timer does not equal -1. So if we've taken damage, then do our palette swapping until at such time that we run out of, until the damage flash timer is done. Every other frame, so every 2 frames, then what we want you to do is increase the palette index, and we're using that wrapping code again. So palette index ++ between 0 and the sprite underscore get width of the palette sprite. So in this case, 4. So we're looping between the first and the last pixels possible in our palette. Okay, so I hope this all works right. At least, I mean, yeah, I hope it all makes sense to you, I should say. All right, now we should be able to see him. There he is. Look at him doing his thing. A little bit of walking. A little bit of walking. Then back to idle. A little bit more walking. And idle again. More walking. And of course, we take damage. And we're still facing the wrong direction when we take damage there. I don't know exactly why, but, you know, whatever. And I haven't actually set up Link with his draw stuff either. So if I come back over to the Link here. So we had all of this. So I had basically said, okay, we're going to only use this for the time being until we get around to setting up the damage and everything. Well, now's as good a time as any to set up damage for Link since we got it. So let's take this, and we're basically doing the exact same thing with the bit here. So when the flashing timer is running, swap my palette through the different palette index sprites. If the iframe timer does not equal -1, then every 4 frames draw me as normal. So once the flashing timer has reached -1, then as long as the iframe timer still hasn't reached -1, every 2 frames, so if iframe timer mod 4 less than equal to 2, this is also available as a script I've made. It's called, what is it? Interval. Then draw me. Otherwise, don't draw me. So it's basically saying every 2 frames draw me, every 2 frames don't draw me. So I blink in and out of existence. Otherwise, just draw me as normal, right? Let's take a look at how Link looks when he takes a little bit of damage. This will be fun. So, there we go. And that's how we know we're still in iframe time. Huh. That was a weird little bug there. Trying to replicate it. Oh well. I'm sure I'll figure out why it happened eventually. There we go. If you look, you can see I managed to get link. You can't see me. I'm pointing my finger at the screen right now, but you can see that Link's hitbox is a couple pixels deep into the tile wall there. That shouldn't happen. So somehow I managed to get Link stuck into the wall there. So I'll have to. Well, I haven't put in the buttons for it for being able to. Reset the room, but I wonder how I managed to do that. Well, I'll have to figure it out eventually. Well, that's the way it is with code. Sometimes, unfortunately, you do things and then there's bugs that you weren't really thinking about. Anyways, looks like we're good. Let's get stopped at this point, and I'll let Past Me take it away with some Patreon names. I'd like to thank my Legacy Patreon sponsors, James Burton, JD Lowe, Suli, and Vezia. I'd also like to thank my current Patreon sponsors, Kenneth Klein, Vladimir, and Jamal. Thanks to your support, the NESGameMaker is much cooler, and I'd like to wish you all good luck with your programming.